Welcome to our first webinar with Coding and Robotics for 2025, and a very, very happy new year to everybody. I hope this year is going to be phenomenal for everybody, and that everything that you lay your hands on turns into magic in your classrooms, especially with the coding and robotics. And so I see Karen smiling there at me. So my name is Ricky Steenkamp. I'm a project manager at Macmillan Teacher Campus, and I want to just welcome everybody in this session. We've got, I think, 3 webinars, Karen, lined up for this year. And we've got a couple of coding and robotics workshops also lined up. And we also have an artificial intelligence workshop lined up, 2 of them, in fact, lined up for this year when it comes to this type of theme or a topic. So please look out for social media. If you haven't registered for those, you are more than welcome to register for them as well. We are very, very glad to have you here with us. Just a quick note, we are no longer using the GoTo training and GoTo webinar platforms. All of our workshops will be held on the Microsoft Teams and Microsoft webinar platforms from here on out. I think it's a lot easier for people to join the sessions. And I'm hoping none of you struggled, and I'm hoping none of you have tech issues this afternoon. So just a quick thing, this is the Microsoft webinar platform that we are on. It is almost very, very similar, almost identical to the normal Teams meeting platform. So look out for the little chat icon at the top there. You can interact with us and ask us questions through the chat. I'll be manning that and then I will forward those questions to Karen so she can answer them for you. And then Karen, I see the raise hands icon is now active once the meeting has started. So you can interact with us. If you're happy with something that you heard, you can raise your hand and you can react. You can send us smiley faces. You can throw flowers at us, anything like that. But please be active in the call. And then I want to also then introduce our presenter to you today. She is no stranger to you and to Macmillan. Karen is somebody that we've been using for a very, very long time. Karen is an absolute expert when it comes to anything remotely coding and robotics, remotely artificial intelligence, and for that matter, remotely anything tech. You are in very, very good hands today. And Karen, thank you so much for, again, making yourself available and sharing your expertise. I'm going to hand over to you and mute myself. Thank you very much.
So, hi, everyone. Today, we're going to explore unplugged coding. But let's go a little bit back before then. So in June last year, the coding and robotics curriculum was set up. It's got 3 main strands. There's a coding strand, there's a robotics strand, and there's digital concepts. At the top, you've got your 21st century skills of communication, collaboration, creativity, and perseverance. And at the bottom, you've got your methodologies of design thinking, logical and critical thinking, and computational thinking. And we're going to be doing webinars about some of those, as Ricky said, later in the year. So for me, when we're looking at coding, we're looking at developing the children's computational thinking skills, which is decomposition, pattern recognition, abstraction, algorithm design. But for me, the exciting thing is they've added debugging. Even though it's not an actual computational thinking skill, it's a really important skill that children need to look at. So today we're focusing on coding. So let's have a look quickly at the different types of computational thinking skills that they focus on. So in the curriculum, it describes algorithm design as defining a precise sequence or steps of instructions to perform a task. An algorithm is a set of rules or instructions that anyone can follow to perform a task or solve a problem. So for example, when you're looking at a world map, here we've got, I'll put the wrong one here. This is abstraction, where the children, you need to then look at the longitude and latitude apps. I'll come back to abstraction. So abstraction is looking at the detail. But when we're looking at algorithm design for littlies, you can begin with an instruction card and build the algorithm around that. Then if we look at decomposition, decomposition is breaking things down into smaller parts. So it's making them into manageable bits. When you're trying to solve a problem, not looking at it as a whole, but looking at it the little bits and pieces. And for me, this activity was a really cool one, where the teacher had just taken a range of different half moons and put them in, and then had a huge tub of colored lids. And the children then had to match the code at the top into these different shapes. A really simple way of getting them to look at decomposition. Then pattern recognition is looking for the patterns within a space, recognizing the same kinds of things that make a pattern that then help you to solve the problem that you're trying to do. Looking for the similarities and the differences to make you really recognize what you're working on. So an example of that is if you're looking at a heart monitor and seeing the regular heartbeat, and then if it's irregular, that attention needs to be given. So seeing how these kinds of things are actually used in everyday life. An example might be that you've got pattern cards that are made that have got patterns on, and the children would put beads or seeds or little pom-poms like in the picture to build the same pattern. And then when looking at abstraction, so abstraction is focusing on the relevant information and ignoring the unrelated information. So honing into the specific things that you want. So here you're looking at focusing on detail. And again, look at the example that's over here, which I thought was a really great one. So the children are given a board of shapes, and they've got two wheels to spin. The one is a color and the other one is a shape. And they've got to find the color and the shape that the wheels have spun on the board that they've been given. They really have to focus on what the wheels have said and then go and find the object on the board. I think that's a brilliant example of abstraction. So in the curriculum, there are a range of high-level competencies for coding robotics and for digital concepts. So let's look at the coding ones. They speak about apply computational thinking skills to develop a set of logical instructions to solve a problem, to present a simple coding solution using symbolic or written statements representing a sequence of commands, single repetitions, and conditional constructs, to interpret and execute the given symbol or set of commands, to debug a given symbol or set of instructions, to evaluate the given solution towards potential improvement, to recognize and interpret patterns in symbolic sets of data and visualizations, and to create and complete patterns to represent a particular data set. All of these go from the grade R all the way through to grade 9. So what is unplugged coding compared to coding? Well, unplugged coding refers to the learning of computer science concepts or computational thinking skills without a computer. So it involves activities such as games or puzzles or physical manipulations of different types of things, or looking at how data is represented and being able to sort and manipulate that, or looking at other fundamental principles, but from a practical point of view. So let's begin by looking at what we would do in grade R. So first of all, if we're looking at generic sequencing in everyday life scenarios, you might do something like eating a meal. So for example, you get the children to look at the different images and decide what order they need to be in and what is happening in those different pictures. So here we've got a set of a child eating a meal, and they would have to talk about what order do they need to put it in. Making it really practical for your young children is very important. Get them to find sequences, look for comic strips, look on the web for different things. There are a range of different resources that you could use within the space, but making it very practical for them. Then we look at simple pattern recognition and completion. So for the grade R's, you're basically looking at two different items in the pattern, and you would start off by saying what comes next. And they would have to then be able to tell you or place the item in that space. You might then move on to simple numbers when they're able to recognize them and they can see what comes next there. And then you could have pictures that are abstract, that they are then put into a pattern, and looking at the images, they would then have to decide what comes next. Another simple pattern recognition one is something like this, where you use a baking tray and you have cards with different sequences or patterns in them. And the children then use the baking tray and balls or buttons or whatever you've got, and then put them into the baking tray in the order that they have been given. So having to recognize and match what they've done. Another activity in terms of then going on to simple sequencing, what they need to do. So you might have cards with different numbers from 1 to 4, and they then have to match the card to the image. So it could be a worksheet that they've got to draw a line to. It could be a card that you've got that they've got to match the 2 different cards and putting them into the order or the sequence that they're going to work in. Then you might get onto the beginnings of coding, where you have a simple picture or you have 2 items and you give them a range of coding cards and you say to them, okay, so how does the octopus get to the fish? Which arrows would you use? And they would then place the little arrows in between it. They would begin with 1 space and then slowly move to 2, that they wouldn't actually be doing turns and things to start with. They would just be going straight. Another simple sequencing one, which for me is really cool, is looking at these number columns. So it's building your maths number concepts, but you can also then be showing how it actually works. And you could have a range of those for your children, just like they've got over here. And they could be building different patterns across it to show how it's added up to the number. This activity over here with a little girl working with the rice and grabbing the things, here's the little clip, is to show how you can actually get them to be fiddling in a bowl and pulling out the items that are needed. For me, this is also another really great activity. So it's textural, it's really tactile, and they've got to be finding the shapes according to the sequence that you've given the children that they need to find. Then we move on to algorithms and simple problem solving. Here they would move they would use 1 arrow until the turn for your littlies. The first kind of coding on a board that they would do, rather than going block by block by block. And so you would give them the board and you would have the drawings, or they would put the pictures be where you want them. You might even have the route plotted out for them to actually help them get there. So then they would actually see how it's going to move. And it's 1 coding card per block that's reached the end of the wall. And that's your first type of coding that you would look at. But then also think about where you could be doing this. So it doesn't all have to be on their desks. You could be outside, where you could have a grid or a hopscotch where they've now got to follow the instructions or to complete following numbers, or the way they move their feet in terms of what you want them to do. You might use something like hula hoops and giving them instructions in terms of how they should move through the hula hoops. So remember, an algorithm was a set of instructions. So the children are following the set of instructions you've given to complete the task. And here you could be using all sorts of things within that space to really make it exciting for them. The next thing is they need to look at debugging. They need to debug, they need to reflect, and they need to improve what they've seen. So say, for example, if we go back to the similar pattern that we saw earlier, they need to look at it and see, what's not working? What's wrong? Get them to find the mistake. And this you can get them to be doing in every single activity they do at school, even the things you're asking them to do that don't relate to code. Get them to start self-assessing themselves and saying, did I make a mistake? If I've made a mistake, how do I fix it up? So for me, that translating into other schoolwork can have all sorts of benefits for the children. So here they would say, okay, the single teardrop's the one that's wrong. Okay, so what do we need to do to fix it? So they need to then take the wrong card out and put the wrong card in if you're using cards within the space. So getting them to really think about it. If you're using something like your little dogs and where they've got to go, you might give them a row with the pattern cards, and they now need to say, okay, so we've got to go to the end. Which one do we need to do? Which one is wrong? So they would find out which one is wrong, and they would then go and change it so that it solves the puzzle. Getting the children to work in pairs works really, really well in this space. Getting them to talk about it and discuss how they're going to solve and fix the problems. And here are a range of other spaces that you could consider. So think about having a big grid in your quad, or a paved space that you've got at school that's permanent and that you can take turns using. Or if you've got a big cement slab where you can go and draw with chalk lines on it. Or what about creating a maze like the top picture, also out in a space, and the children can then be drawing the solutions in it. And if you draw it, or if you make it in such a way that you can go in and alter it slightly from time to time, that the children don't have the same puzzle all the time, that's even more exciting. And then think about putting things on like the wooden floor. So instead of putting it on top of your carpet, if you've got a classroom carpet, roll your carpet up and put your grid under your carpet, and then roll your carpet over that for when you're not using it. I remember years ago, long before coding, I had a grid like that on my floor that I would then roll the carpet up and we would do activities on, and then roll it over. It lasted much longer than trying to keep it on top of the carpet. Now let's look at grade 1. So in grade 1, we're looking at generic sequencing in everyday life and algorithms. So what could be an example there? What about doing the washing? Getting the children to talk about what it is and how they would actually sort the items within that space. But then what about creating obstacle courses for the children to crawl through, to jump over, to walk over, where they're then having to follow a sequence and pick up either a set of colors in a particular order or numbers in a particular order. And here with grade 1s, it could be counting in 1s, it could be counting in 5s. As you introduce the different groups, you could then be introducing them to the different number patterns that they would then have to walk through and pick it up. The same could apply to letters. The other thing that you could do with this is you could divide the children into groups, and they could set up the obstacle courses for other children to do, which would be really exciting for them as well. Get the children to create the courses. I remember creating courses, or groups of children creating courses to solve problems also long ago, and it worked really brilliantly, particularly in the foundation phase. And the others got so excited about walking through another group's puzzle or obstacle course that they created. Then think about the different kinds of pattern recognition that you want your children to complete. So now you've got different ones to find at the end, but also if you look at the example, it might be tracing a line of a pattern. It might be looking at different types of layout of a line. Perhaps it's shapes 2D and 3D. Perhaps it's images that you're using, but you could also be doing real things. So you could have patterns with toys that you create. The toys that you've got in your classroom, set of dinosaurs or farm animals, and you could then be making patterns, or the children could be making patterns, and other children need to come and copy the pattern that's been made. What about looking at movement patterns? So getting them to create a movement pattern that others can follow. So for example, and then the others could actually copy that. You could do the same with full body movements and getting them exercising almost with their types of movement and others following. And you don't always have to be doing this. You can set up the activity. You could either have lots of small groups that each group then decides their own, and the small group follows the leader. By allowing different children to be leaders, you're building their self-esteem, you're getting them to understand the concepts, and you're getting them to move and get rid of the energy within the classroom space too, and they love it. Think about the different kinds of resources that you want to do these kinds of things. So these green arrows on the left actually come with the robot mouse. Those are the kinds of arrows that you get, but there are lots of different kinds of arrows, or you could make your own. Think about using shape cards. And for the shape cards, the children then can remember the shape that you're given and do the action. So now, for example, if the yellow circle is your hands on your head, whenever that comes up, then they've got to remember that they've got to put their hands on their heads. Or if the purple square comes up, that you've got to stand to attention, then they've got to remember, when that comes up, I've got to stand to attention. And so they could choose 3 or 4. The groups could decide what their cards mean, and they can then each take turns making their own code that others have to follow. Again, really great in terms of building memory, reinforcing literary skills, reinforcing long-term memory, all sorts of things like that. And then you could also just have movement cards. And when those come up, they move according to the shape of the movement card. We now go on to in grade 1, looking at simple sequencing with elementary problem solving. So now we're saying to them, okay, so you've got a problem. Here's your board. How are you going to actually move? In this space, in grade 1, they don't actually use a turning arrow yet. They only use straight arrows. But now, instead of moving to the end of the color movement before they turn, they're moving block by block by block. And so here they're saying they're moving 1, then they've got to go down 2, then they've got to move 2 across, then they move up 1, and then they move 2 across. So the children really have to solve the problem. My suggestion is you have 2 sets of arrows, one where they build the code, the other set is actually to place it on the board. So one group can write the code like it is at the bottom from the little boy to the house, and the other group then follows the pattern that's been made and has to place it on the board, and then they check and debug and make sure that it's right. So remember that there are no arrow codes. They're using forward and up and down. When we're looking at algorithms and problem solving and single command, we can also then start looking at how do they actually find us? And a great way to get them to understand repetitions or repeats is when you're starting with something simple like Lego blocks, or if you've got other building blocks, or even if you've just got 2 buttons or colors that are the same, something that's really, really simple. So here you can see you've got a build it card, which looks like Unifix that's put together, and then the blocks are built next to it within that space. So the first thing that you need to get the children to look at in this instance is, what are the colors? So in this instance, we've got purple, and then we've got green, and then we've got purple again. So make them aware that what the sequence is, even when we're not looking at numbers. And now you need to say to them, are there repeats? So they might say, what does repeat mean? So you need to say to them, are there 2 or 3 of the same thing next to each other? And then when they've looked at that and they say, oh yes, look, there are 2 purples, then there are 2 greens, and then there are 2 more purples again. So breaking it down really easily for them when they begin to do this. And then they can begin to count them. So they say, okay, so we've got 1, 2 purples. And so then they write it on the board under the color instruction, 2. And when we're doing coding, they write the 2 in the circle. So practicing like that is useful. They then do the same for the green, and then they do the same again for the purple. And so you're getting them to do it from a really simple point of view. You're not even talking about coding, but you're creating an awareness of what the things are. You're showing them how the things have been repeated and getting them to count them and note what they are. You could be getting the children, again, once they've understood this, to make their own patterns. So they could be creating pieces of bricks that fit together, or blocks that fit together, or they could be putting beads and things in a particular order, threading them onto a thread, or they could be having buttons or colored containers or lids in a pattern. Then you could have cards like this that are blank, and they then move to the new group, and they then have to count, color the little color that which is ever filled in, so they can just use their colored crayons, and then count how many repeats there are in each of them. And you could have a whole lot of those that children are reinforcing that skill before we even talking about putting it into code. Then if we now take the same idea and we go back to the boards, begin with boards that they're familiar with, and don't necessarily change the picture or even the instructions. So they've solved it, they understand it. Now you're introducing a new step. So just build on the knowledge that they have already. So now you're going to say to them, so we've got this set of code. Are there repeats? And again, they will say yes. And then you say to them, okay, so this is how we now write the code. Instead of having to draw every arrow, we say how many underneath the arrow needs to be there. Under the ones where there is just one arrow, we don't need to write anything because it's just one. We know it's going to be there. And so you can then get them to double check this. They could build the long one on the board and see that it's right, take it off. And then they could take the shortened version code and they could build it on the board and check that it's right. Remember to get children to swap boards and check each other's blocks and coding. Again, you're doing the debugging and you're reinforcing the skills. Again, you're not using any arrows, turning arrows. It's still just straight arrows within the space. Now let's have a look at an example of grade 1 debugging. I've mentioned it a few times, but just think about what you could be doing. You could give them 3 examples of different types of code, whether it's long code or shortened code, you can decide. And they can then look at the picture. You could give them the arrows and they could literally plot them out and see whether it works or whether it doesn't work. So it doesn't have to just be something where they're looking at it and having to guess. For me, I think it's having the real cards and putting them on the board as well as in the instructions. And then saying to them, okay, so now you've put them on, which one is the correct one? And when they've found it, double checking it. And then if you've done the repeats with them already, they could then take that one and turn it into a shortened version and double check it if you've started with a longer version. So they need to then record it. Let's have a look at grade 2s. With grade 2s now, with the sequencing, you're now looking at adding words and sentences. So it's not just images. Yes, of course, you can still do the image ones, but now think about how you're wanting to build reading for meaning, you're wanting to get the children to be understanding more, you're introducing more maths problems where they're having to read. So getting them to put things like scenarios into sequence makes sense, that they're also reading. You're reinforcing other skills that you're trying to develop within your classroom. So here we've got 5 instructions and they're looking at what is the order that we need to be when we get ready for school. I eat breakfast, I get out of bed, I walk to the school bus stop, I wash my face and brush my teeth, I put on my school uniform. So what is the order that they would do it? Would they get out of bed, wash and brush their teeth, put on their uniform, eat breakfast, and walk to the school bus? What I do want to say about this is that the order might not always be the same. And you might have a child who says, no, I have to go and eat breakfast and then I go and wash and then I get dressed. Or another one might say, I bathed the night before, so I just go and brush my teeth. And you can have really good discussions about all sorts of topics from your life skills in terms of don't forget to wash your face, don't forget to brush your teeth, remember to eat your breakfast, all those kinds of things. Some children might eat their breakfast on their way to school in the bus or in the taxi because it's just too early. Allow that kind of discussion. But getting the children to be aware that they can arrange them is really important. So having them on separate slips that you can start off by cutting them out and reorganizing, that they're not having to write the whole sentence, that they can actually just be reorganizing them. So they would then work out the order, would also save time in your classroom and would still be developing reading skills. The patterns now within your grade 2s also begin to change. You now begin talking about perhaps adding more options that they can choose from, adding more levels of difficulty in terms of what's missing, how do you add more, and even having pictures or orders of real things. These are suggestions in terms of the curriculum. Remember, if your children are more advanced in grade 1 or grade R, it's not going to hurt them to do these kinds of ones earlier. But this is just the kind of suggestion that's within the space that we see. Another kind of pattern recognition that you could do in grade 2 is something like teaching them Braille and getting them to recognize Braille and how that works and getting them to actually solve code. I remember years ago, we used to do it as a technology activity where we would actually give the children the Braille code, and they would actually then make their paper versions, and they would have cardboard that we would use the awls with, and they would press the little holes in on the card, and that you could then feel the letters underneath. We did it in a reverse fashion when they did it, so when they turned it over, it was the right way around. But the children actually loved it, and they began to feel the bubbles and be able to interpret the words. And there were some really great stories around how they tried to write other letters for other people, and there were secret codes and all sorts of things that were happening with the littlies. So this one says hello, but get your children to play within the space. If you can get an example of a Braille book or Braille cards, those are also really great. They can actually feel them and see them, that you can cut those out for your students to use and move around and make words and statements with them. Another great thing you could do if you're doing this, invite the Blind Association to pop around to your school and have a talk with the children when you're doing that. They also love that, and it's really useful. So we're now looking at sequencing with problems, so moving forward. Now what's introduced in grade 2 is a jump. So a jump is where a character can move over a block. So they're moving block by block. They can't move more than one block at a time. But when they hit a jump, they can jump over that block. So now we've got a new feature or new arrow that's introduced for the children to use within their code. So you'll see here that they move forward, they jump, they move two, they move jump, they go forward once, and then they go two to get out. This piece, I just want to say, I took straight from the curriculum. And in the curriculum, it talks about not showing the ones, but the picture they've got there as an example, it's got the ones on it. You really don't need to put the ones on when your children are doing it, just the numbers 2 or bigger for the repeats. They then carry on within these ones, and they introduce turning cards where you're turning left and right. So in grade 2, you're now introduced the turning arrows as well. And here again, you've got where the children would move and then would turn. So you've got move 3, turn, move 3, turn. So if you look at that, you will see that the turn is actually on the same block. You end up putting 2 arrows in the same space. And if you watch what happens when you're using a robot, it turns and doesn't move, and then it moves forward. So when they're coding or when they're building it on their block, you need to tell them that you're going to put the 2 into the one space. Then the algorithms, now using words and symbols, have a single command repetition and additional commands within the space. You'll see here they're trying to collect carrots. So which arrow can get you to collect the most carrots? So help rabbits to collect them. So we've got 3 different paths. We've got A, B, and C. Which is the longest? So you would get your children to explore and count the blocks and say, which one is the longest block, longest route that they need to get through? Which one is the best one to collect the most food for supper along the path? And so you could be getting them to solve problems in a range of different ways. Getting your children to create their own puzzles and boards within the space is also possible. So think about how you can get your children to be doing that within the space. Another thing that's added in grade 2, so lots of new things in grade 2, is if and then statements. So here we've got a rabbit who doesn't like purple carrots. So then if he sees a purple carrot, he's got to go the other way. So now the children have to really look at the board, look at the instruction, and then see what's working. If you're using Scratch and things, it's your if-then statements that you code within there as well. So now they've got to think about how they actually do it. And within your code, you then put a separate little card on top to say, hey, this is where we've got an if-then, and here they've used a pink type card within the space. So getting the children to think about how they're moving in the space and which one they're going to move or which way they're going to move to really complete the problem. So if something happens that they don't want, what are they going to do? For grade 2, for debugging, we're now looking at tracing and improving as well. So if we now look at things like following paper folded instructions, don't just give them the set of instructions as it is. Cut it up, add extra bits and pieces, and put it into a really mixed space that they've really got to solve it and debug the order that they've got to make this activity in. So first of all, they need to debug. So what do they need to do to debug? They need to remove the things that will mess up their little folded decorated paper dog. So get them to cut it out and put those things on the side. The next thing they need to do is they now need to fix the order. So they need to reflect on what's happened and then you see, how do we improve this? So, So we're going to say number 1 and then number 5 and then number 7 and then number 8 and then number 10 and then, number 7 and number 10 and then number 8. So getting the children to really look at it. If you can get them to cut it out and put them in the order and glue that down and then follow the order that they've made to make whatever the folding activity is really useful. If they've then glued it incorrectly, they will then pick up the other bugs more easily than if they've just got it moving around and maybe it gets blown in the wind or other things in the classroom. So cutting them out, taking away the things that they don't want, and then gluing them in the order they want, and then folding the piece of paper can get them really to be thinking about how do they debug and improve what they're trying to do. Now let's look at grade 3. In grade 3, again, we start with everyday problems, and great ones to do here are getting them to write recipe instructions or follow recipe instructions. So maybe it's making a sandwich, maybe you can make scones at school, maybe it could be fruit sticks that you make, but having to really put the instructions in the order that are correct and then actually doing the instructions. This could be done as a group, this could be done as individuals, you decide how. But think about how they've got to actually physically end up with a product by following the instructions. So we looked at a product just now, paper folding. Here we're looking at something in terms of physical that maybe they'll enjoy eating. Another scenario might be something like washing hands. But when you start doing now in grade 3, definitely add in things that should not be there, things that are curveballs. So again, give them the activities and say to them, find the correct sequence that they want. So if they put the correct sequence out that they've built, they then look at, is there anything that should be ignored or not included in the space? And in this instance, it's yes, the instruction of do not wash your hands. And so you could have really great discussions, and almost every single life skills topic that you do, you could have sequences made where the children could be reinforcing these kinds of skills, and you could be tying it into your other subjects that you're teaching. If we're then looking at pattern recognition for grade 3, think about the kinds of things that you could do. Let's look at if we make a growing pattern. So if we start with 1 dot, now we need to go to 3. What would our next one be? So now we would go to 6. How does that look? So we would take our 3 and we would add another triangle of 3. So what would our next one be? So now we would move to 10. So 10 would be our first little triangle, our second triangle, and now we would add a third bigger triangle with 4 dots in it, which then makes 6. So what would our next growing pattern be? It now would be 15. And so you could create really big patterns like this. This is just one example. You could build a car where you start off with the body and then you add the wheels and then you add the top. You could get the children to think of their own growing patterns. It could be a flower where you've got the stem and then the bud and then the flower and then the little petals that get added. So you could really think of all sorts of things that your children could do to make growing patterns. So yes, you would still be reinforcing the patterns from grade 2 and grade 1, but now you're adding another extension or dimension to your patterns. So the patterns become more complex as you move forward. What about making patterns now with sign language? We've spoken about Braille, but what about sign language? Sign language could be another great one where they could be teaching, where you could be teaching them about patterns. So looking at the signs, understanding sign language. Again, you could invite the Deaf Association in to come and speak to your children. You could have somebody teach them real sign language that they can communicate. They could learn from cards as well. But it's a really fun one, especially if you start teaching them how to say hi and things like that. They can come into the classes and greet each other like that. So what do you think this says? What is the word? And so the children could then be signing words and their friends need to work out what they are saying. It could be a really fun one and a different form of pattern recognition that you could be showing the children. Your sequences then become more complex in terms of the complexity of the pictures of your grade 3s. So they're still simple sequencing, but now your pictures have more detail that they've really got to look at and see in terms of the complexity of it. So they need to talk about in the first one what comes next. So they would have to find the pattern and put it in. For the bottom one, they've got to work out what's next. So again, they've got to work out what is the sequence. And once they know the sequence that's there, they're able to work out what's missing. So again, they've got to really be critical and look really carefully at what they've done and how they are doing it. When we look at the algorithm design, looking at now, we're looking at moving forward and turning left and right, but the patterns now become more complex and the instructions become more detailed in terms of what they're going to do. Remember, they would still, the new one you would add here, or you would reinforce here is jump. So in grade 3, they would also be doing jump, and they would then be solving the problems in terms of jumping the solutions. And then what you would also be looking at is they would now do pick up. And what they need to do with pick up is here they have to go and they get given the instruction that they need to pick up things within their code space as well. So think about, again, the boards and things that you would build and how you would build them and how you would add all these different kinds of developments within the space. If you've got an outdoor space, think about how to accommodate your children from grade R all the way through to grade 3 or from grade 1 to grade 3, depending on your school. Make spaces that can be used by everybody and easily used. Make them to be spaces that can be easily adapted and adjusted. Here you can see they're using cones for their one, but you could use anything in terms of how you could be using it within your space. Explore making or getting floor mats. So you could order and buy big floor mats. But the other thing you could also do is you could go to a printer and use the fabric like this of the pull-up banners and get them to print mats for you on the pull-up banner material and just not put it in the frame. It's brilliant for working on. It's really durable. And you could have those, a few of those created within your school that you share between your different grades or classes. They also, the printing is not expensive in compared to what some of the coding products go for. Then if we look at, I forgot to change the 2 to 3. If we look at then debug and reflect for grade 3, we now got to first of all see what is the problem and where is the bug. So the first thing they need to look at is where is the sequence. We need to teach our children where the sequence is when they need to debug. And here you'll see that there are 6 different pictures in the space. And so we've got the 6 at the beginning and the 6 at the end, but the one in the middle, there's a problem. So now they can say, okay, so where's the problem? And they can work it out from there. And they can say, oh, look, we've got a double of lines going down that we don't have in the other 2. That's our problem. So now what they would do is they would take it away, and they would say, okay, we're now going to rebuild it, and then double check it. Does our sequence fit in the space? So when we're talking about grade 3s, the instructions become, become more complex. The things that you want to do with them, get them to be really thinking and solving. So now you're not just doing simple patterns. The complexity of the images becomes more, the similarity, so it's more difficult to differentiate. And all of these skills also help for the development of maths and skills, maths and literacy. It gets them to be reading the pictures, which then reinforces their literacy skills within the space. It gets them to develop or reinforce their counting skills and observation skills, which reinforces their math skills. So think about unplugged coding as really meshing into the rest of your curriculum, thinking about how it overlaps within so much that you do. So we've spoken about some of the ones, and some of these you've seen. Here there's a really nice grid, and you can see it's on the teacher's carpet. And like I said at the beginning, I wouldn't put a grid like that that's taped on the carpet. If you've got a carpet that can roll up, I would put it on the floor underneath. It lasts much longer. Where you put it on the carpet like this, a little soul walks past and trips on it, or it gets unsticky and it just pulls out of place. So think about putting it where you're not having to redo it every week. The one in the middle over here with the circles is a really, really useful one, where there are no lines. It's just the colored dots and the arrows within the space. So the space is plotted using dots. For me, that's also a really nice one. And I love the hula hoops outside on the grass. I think sometimes our children don't play outside enough. And so you could be doing fun activities, taking the children outside for those types of things. But then thinking about using a range of resources. What about real leaves and flowers? Do you have a garden at school where perhaps in spring you've got a whole lot of daisies and you can go and pick the little daisies? Or perhaps you've got trees that have got lots of leaves. I know when I was at primary school, we had huge big poplar trees, and we were allowed to pick the poplar leaves, and we would make chains with those. You could make coded chains of poplar tree leaves or other leaves like that you could get the children to be exploring. What about boxes of toys? In the plastic insects or dinosaurs or farm animals or wild animals, and they could be making sequences of those. What about toy cars or little dolls? Just really be creative around the kinds of things that you could be using that don't have to be breaking the bank. Perhaps you could even ask children who've got ones at home that they don't play with anymore, that you put them into a space within your classroom. The insects and the wild animals and the dinosaurs are always useful when you're teaching those topics anyway. So if you then use them in those spaces and then add other ones as your debugging activity component, so vegetables with the dinosaurs, or wild animals with the dinosaurs, or farm animals and insects, and get the children then looking and playing with those. Just be really creative around how you could be exploring and experimenting with the children. Then think about useful things that perhaps don't cost a lot of money. Or egg cups or baking trays are really, really useful. The big egg boxes, the 36 eggs, can make a really great pattern that the children could be using. And it's a really nice container that they can see the separate elements within the space. Ice cream sticks, pom-poms, Unifix blocks, all of those can be useful. Colored cups that they could stack together or put out can also be really useful, that you could be using to show the children different patterns and codes. The curriculum then has a little aspect where it talks about, there's the optional programmable robots. Here are just some. The B-bots or blue bots and the robot mice now actually cost a very similar price. The robot mice have gone up so much in the last while that they also now are, in most instances, over 1,000 Rand. The B-bots and the blue bots can also be bought in a set or a tray. So you can charge all of them at the same time, which is really useful. The robot mouse uses batteries, but the batteries last a long time. Dash and Dot are really great robots. They're not cheap, but they're really useful, and you can program them. If you've got tablets at school, you can program them. The coding program for them is a drag and drop, a really very cool drag and drop with links and shapes, so no words, and they will quickly learn what adds a sound. They can also record onto it themselves, or they can make it move and turn or follow a path. Sphero is really similar, also durable. You can also get a cover, a plastic cover for it. So if you've got a school pool, you can have them programming it to be swimming inside of the school pool as well. And you can program it really well to move through your different paths and patterns that you, boards that you saw, like the ones of the pictures that we showed earlier. So for me, the Dash and Dot and Sphero are really great from using a device point of view. The Bebot mouse and the robots are really lovely. You don't need any other device, and you program it by using the 4 arrow keys. So the one in the front for both of them moves it forward. The one at the back moves it, makes it go back, and then it can go left and go right. And both of them work with the control of pressing the center button, and that actions the code that they've done. They can clear the code and start from scratch, or you can keep building the code on and on and on. Then you can look at some other resources. So Scratch Junior is a really great app. If you've got tablets that you can begin using, it works really effectively. And by the middle of grade 1, you could be using Scratch Junior. Boats by Tangible is their free online game. If you know Tanks or Rangers, that's their free version. If you want Tanks or Rangers, you can buy those. And then Scotty Go would work really well from the end of grade 1, beginning of grade 2, when their reading is great. And that you could probably use all the way through to grade 7 with the abilities and the lessons and things inside of Scotty Go. Then you've got a Bebot app, which takes the children through a range of activities and teaches them how it moves on a board. It's also really great. Code Carts, Coding Safari, and Lightbot app all have the same kinds of skills and resources to teach children the basics about coding. So when we look at this new curriculum, we'll see that there are a range of different things. This picture actually shows all the way from grade R all the way through to FET. So all the things we've spoken about today that happen in the foundation phase are over here. And that includes all your unplugged coding. And then if you do want to use the optional digital or devices within that space. So I hope it's given you some ideas of what you could do with your lessons. I hope it's given you some thoughts about things that you could explore and look at. I hope it's made it easier for you to be able to explore and play. Thanks, everyone.